Okay, now we are moving to our speaker tonight is Mike Buller. I think I need to give you an intro about my CTO, the company I work for. You know, he was excited. He came from a CIO, the 100 meeting, and I said, Vignesh, see, you need to hear this. You know, I heard a lot about this particular presentation. So he was so excited, and he explained me everything what happened. So, you know, obviously being in an IoT, I was fascinated, and I thought, you know, Mike, I need to talk to Mike. You know, I just sent him an email to Mike. It didn't even take more time. So I got a reply back from Mike, and he was so excited to come and present us on the same topic. So thank you, Mike. Thank you for coming along. And so Mike works for Fujitsu, as you may have seen. He's the GM for sales, 30 years of IT experience, software development, sales, consulting, you name it. I think Mike has done it. So I think it's good to have somebody from Wellington presenting on IoT. And he's not just going to present on IoT. I think he's got a very good interest in that space. Which is exciting to see somebody who's passionate about IoT, being involved in IoT, and giving us a presentation on IoT. Without further ado.
Hello, first of all, thank you for having me along tonight. Your boss came along and saw that presentation. What he didn't tell you is that it was at an event that took about 3 hours, and my presentation was 5 minutes long. So I think everyone was really pleased that my presentation was only 5 minutes. That's why it was so good. But I was talking to a room full of execs and CEOs and CTOs who really kind of got the theory of digital and everything emerging tech and AR and machine learning, artificial intelligence and digitalization. But we're struggling with a way of actually explaining it to non-technical people. So the idea of that presentation was to put it in context and go, here's a really simple story that you can tell to explain to people what digital might mean, and here's a way it might work. But what I'm going to talk tonight about is that same story, but I'm going to expand on it to actually give you the meat and the sandwich as to what is in those steps. And what I'd really love along the way is to ask me some questions, because although I'm currently in sales, I do have a bit of a technical background, and I love IoT. I'm going sailing with some friends to Tonga at the end of the week. I'm going to be out of all technology coverage for like 10 days. There's no internet in the middle of the Pacific Ocean. And my wife said to me last night, Mike, what the hell do we do if we can't turn the lights on because Alexa's broken again? Because I was in Australia recently, and something had gone wrong with the internet connection. Alexa wasn't turning the lights on and off. Our home automation system had lost connection to the Z-Wave connection. And my 5-year-old was in there going, it's okay, Mum, I know how to do it, I'll ask Siri. So it's incredible that I've got this 5-year-old and a 3-year-old. If they want to know anything now, first they go and ask Mum and Dad, which is really nice still. But when I can't tell them, I go, I don't know when the mower was last discovered. Well, that's okay, Dad, I'll ask Siri. And when Siri doesn't know, they'll ask Alexa, and then I'll ask Google. And that's the life our kids are living in now, is knowledge is just there, and they just turn and ask. So IoT is all around us, IoT is normal. But as business people, we often have trouble explaining it from a technology point of view to non-technologists. So hopefully what I'm going to explain tonight gives you a bit of a story around how to explain it, plus also some stuff we're doing that is real in terms of helping to reduce worker harm and improve employee safety, which my wife is very keen about because she works for WorkSafe. All right, so in looking around for how to explain the concept of digital, I jumped on the font of all knowledge, Google, and Googled digital. How do you explain it? And I found this from a long, long time ago. It comes from the Journal of Knowledge Exchange, Knowledge Enhancement back in 1893. It talks about digital, but nothing to do with technology. And it talks about digital from the point of view of, to start with something, to get me the data sets, get me all the information you can get, so I can then start to do something with it. Once I've got that data, I need to turn that data into information, because data in itself is useless. Turn it into information so I now know what that means. Once I've got the information, I've probably then got some gaps. I know what's happening, I've got the data sets, but there's things occurring that the data is not telling me why, so I've got a gap. So now I move on to insight. I need to find out why things are happening versus just what is happening, and that's what the data tells me. Then I can move on to thinking about what I might do about it. I know what's happening. I've got some gaps around what's happening out there that I'm not sure. I've got some insight that's now telling me why it's occurring. What can I do about it? What can I change? What levers can I pull to change the situation? Then I can act, pull the levers, change the situation, and move into the learning phase, which is then understanding how that has affected the whole system and start over again. And that was a digital ecosystem invented way back in 1893 in the Journal of Knowledge Enhancement. So this stuff isn't new, we've just applied some technology to it. So now I'm going to apply that same digital story to a real life example we've got going on with a customer here in New Zealand. Now this customer, who will remain nameless, but you can probably guess if you're in the industry who they are, has a whole bunch of workers out there working up these things in incredibly dangerous situations. It's high, so they can fall off. There's a little bit of electricity running around, so if they touch the wrong thing, they'll get fried. And it's dangerous, there's weather conditions, they're often in remote locations outside of coverage, so it's not a safe environment. Therefore, safety is this customer's priority. And their question to us is, how do I use technology, how do I use a digital ecosystem to reduce worker harm and improve employee safety? So, what did we do? We started with data. We went, right, we need to know what's going on out there right now, because if we're going to improve the safety of your people, we need to know what the situation is today. So we put these little things on them, not a watch, but a IoT sensor. This bloke's wearing one. It looks like an Apple Watch with a screen. It's not the most industrially well designed thing. It's robust, it does everything it should, but it's kind of ugly. And it sits on their wrist and it reads everything that we can read biometrically. Now, nothing magic about this. It pretty much reads what any smartwatch would do. Heart rate, accelerometers, that sort of thing. All your generic things, GPS. We haven't done anything amazing with that, but we've done something amazing with the data that I'll talk about in a second. So we've got this on a group of field workers out there gathering some data, about 12 people wandering around, through a range of different roles, those that go up power poles, those that go up pylons, those that work in substations and so forth, gathering the data as to what's going on. And they put it on, they check into the system to say I'm on, so that we know that that particular role and that particular person's wearing it. They come back, they take it off, they put it back in the pool and they check out, and therefore we've got the data from that shift and that person. They also carry around with them an Android phone. This is an Apple phone that you'll recognise, but they carry around an Android phone, and the Android phone acts as the IoT gateway. So this thing connects via Bluetooth to the phone then buffers the data off the device, and when the phone's in coverage, which for most of us would be all the time, but for these guys it can be seldom, it uploads that data. So we're able to capture that data in what we call near real time, or we call it always connected, because there's about a 2-minute delay between something happening in the person's body, the thing sensing it, Bluetoothing it to the phone then 3G, 4Ging it up to the system relaying it back down to us. So it's close enough that we're able to do something. I mean, this thing wasn't designed that if someone suddenly electrocutes themselves, we have a helicopter out there to rescue them tomorrow. In 30 seconds. This was designed to go, let's look at long-term changes that we can make that will improve safety. So the near real time is good enough for what we're doing. So we're capturing all these stats, and as I said, we're not doing anything particularly wonderful. This doesn't have some uber sensor that our guys invented in the labs that can tell us something about a person that a Samsung Gear or an iPhone doesn't, iWatch doesn't tell you. But what we have done is we've taken that data and we've fed it up into Azure. And we've worked with a lot of universities in Japan to create algorithms that then tell us correlations between that data to give us things that your typical smartwatch biometric thing doesn't give. So it can give us employee tiredness and fatigue based on the factors that we're picking up off that watch, the factors we know around what's going on around them, and we can start to match that data to go, this profile shows fatigue in that employee. So just using common off-the-shelf sensors, we're now able to get a set of information that a typical smartwatch or Fitbit wouldn't tell you. So I call it the Fitbit on steroids, but the smartness in this thing is not in the IoT device itself, it's in the data that we capture from it and the algorithms that we use to correlate that data to tell us something. So now we've got a whole bunch of people wandering out there, capturing data, feeding it back to the system, and we load it up into the Azure IoT cloud, and we've got a nice Azure IoT dashboard that shows us what's happening. So we know what's happening. We now turn that data into information. So instead of getting thousands and thousands of points around, this person was in latitude, longitude X, there was an altitude of Y, the ambient temperature was Z, 5,000 times a day, that doesn't tell anybody anything. We translate that data into information. So we put it on the Azure IoT cloud, we turn it into a dashboard, And it doesn't, unfortunately, look as cool as that. At the moment, it's quite boring. It's just a set of graphs and a couple of things. But that's really what you want. You want something nice and simple. Yeah, if you think about, I've completely forgotten the term, where you take a whole bunch of stats and you display it in a graphic.
Infographics?
Thank you. Yeah. Infographics, they're not like this. They are quite simple things that people can look at in a hurry and go, yep, I can see what's going on there. So effectively, we create an infographic dashboard that shows us the status of the team, the employee, some history, some real-time data. And we can go, is there a fatigue issue? Is there a temperature issue? Are they exposed to cold temperatures and getting hypothermia? Is there something going on? Is the sensor working? All those sorts of things. So we've got that now in a dashboard. So for the first time, this customer now has effectively a view of what's happening out there in their workforce, and they can start to understand the situations that their workers are working in. Now that started to bring up some sort of human psychological things, because often they'd be asking their people, all right, can you work an extra shift tonight? And the person would go, yeah, I'm fine with that. He's exhausted. His sensor's telling us that he's highly fatigued and not really up to it. Yet in the past, probably would have said yes, because he's a nice guy.
Yeah, fine.
Here to help.
Yeah.
Keen to do that.
We know that, don't we?
Yeah.
So whereas previously we were dispatching crews out to quite dangerous situations or quite complex jobs that were overly fatigued or didn't have the skills to do it, but were being the right, helpful people and putting their hand up and saying, yeah, I'll do it. We can now match that with actual fatigue data to go, no, I've got 3 of you I can choose from. Actually, you're the guy, you've had the most sleep this week, so do you mind doing it? And that way we can start to match people to situations. So we've now got the data. The data's giving us the near real-time stats of what's going on. We've got the information in the dashboard with the infographics to tell us what's happening out there in the workforce. So we've used IoT. Question?
Sorry, are they keeping these on 24 hours a day, or are they taking them off?
Just on the shift.
Just on the shift.
Yeah, but we don't want to know what's happening at home.
You don't actually know how much sleep they've had. You can just sort of interpret their body actions to judge how much sleep they had.
So the way we determine fatigue is through the algorithms that read off that, so we can tell from heart rate and breathing and movement pace as to whether they're physically fatigued. So I'm not so much interested in how much sleep they've had, because I've got 2 young kids and sleep is irrelevant because you can get woken up every 2 hours. Is their body showing signs of fatigue, and that's what the algorithms can tell us from the sensors. Plus, what shift have they been on? If they've pulled double shifts that week, that's usually a bad sign as well, so we can correlate those 2. So yeah, it's not a 24-hour-a-day monitoring people, because employees don't tend to take too well to that. It's at that point in time, how fatigued are you? So you're looking at 2 things. You're looking at the individual at that point in time, but more what this customer in particular was looking for is trends, situations. Yeah. It's not about whether you're physically okay, you're okay. Is that crew in that situation repeatedly experiencing a high level of stress, or is that particular site often causing drops in body temperature? Okay, we can do something about that, because that's something that under the New Health and Safety Act you should be aware. That's not something I as an employer can do something about. So we've now got information. So gaps. Okay, so we know what's happening out there in the field. We've got the data, it's coming in, we've got the dashboard which tells us what's going on. But things start happening, or they start seeing things on this dashboard which don't make sense. So at 8:30 on a Wednesday night, for 16 weeks of the year, particular crews were experiencing extremely high symptoms of stress for about 45 minutes. And I go, okay, so what's happening on that particular shift? What's happening on that particular job? We don't have enough information. We haven't got correlation. We've looked through all our systems, and we can't see anything that would cause a 45-minute long peak in stress at 8:30 on a Wednesday night for 16 weeks of the year. So then we start to correlate the data that we have with the data. What is it that's causing it? And there's too many variables. By the time you take into account all of the biometric variables that we're getting, the weather variables, the job, the technical details of what they're working on, plus everything that's happening in the world around them, because of course those people aren't islands, they're impacted by everything happening in society and the world at one time. How is any human being supposed to correlate all of that and work out what's happening? It's beyond our cognitive ability. We can probably correlate a dozen variables in a spreadsheet, but you get beyond that, we can't do it. So that's where machine learning comes in, and that's where we start to use machine learning to look for those correlations that just as humans a couple of years ago we couldn't do. But now we can feed it into the Watsons, the AWS, deep learnings, and Google and Azure machine learning, and go find it. So we did. And what did we find at 8:30 on a Wednesday night for 16 weeks of the year that caused excessive stress in the crew? It was a particularly quiet night, so they were watching TV. So that's actually a joke. This company doesn't let their employees watch TV. But that's the example of how it can be something that is completely irrelevant to the situation, yet you could have spent hours and weeks looking into what's in that work environment causing that, yet it's got nothing to do with work, it's got something to do with the external factors going on in the world. And that's why we talk about it's important to bring in external data sets, not just the data you have if you're looking at big data, but the data that exists publicly to find if there's a correlation. So we've got the data, we've got the dashboard, we had a gap, but we've used machine learning and correlation to create an insight, so we now know what's going on. So we know what's happening out there in the field, but what do we do about it? Now the problem is, this company is a business. They may be corporate, they may be government, it's irrelevant in the scheme of things, they're a business and they've got to deliver a certain set of outcomes, supplying power to New Zealanders, with a certain set of constraints, time, money, people, skills, resources, and an overriding factor, which is employee safety. So there's a whole bunch of levers they can pull. Do I pull the employee safety lever 100%? Well, if I only do that, my people will never leave the office. I'll wrap them in cotton wool and chain them to the desks and they'll be the safest workforce in New Zealand. But the lights will go out and no one will have power. So I've got to let that lever off a bit. Do I want to spend gazillions of dollars protecting them in every way possible? Yeah, I could do that as well, and we'll have power and we'll have safe people, but we'll be out of business in a week. So we've got two levers there we can pull. Do I want to slow down the way they do things because that's inherently safer and make them take longer time? That creates longer outages in the power grid. It creates longer to do things. It creates longer to get power to new properties. And in the building process where we're trying to get new homes, we can't do that. And you can work through lots and lots of these different levers. Which ones do I pull? How far do I pull that one? How far do I push that one? What about this one? Or that one? What's the optimal outcome based on some principles that I have as an employer and a responsible business in New Zealand to get the optimal safety measure for my people and the best outcome for my customers? That's quite a hard thing to do as well. And yeah, you could do that with 2 or 3 variables, maybe 4 in a spreadsheet and do some goal seeking and hopefully come up with that looks like the right match. But then again, when you've got 30 or 40 or 50 different things that you could pull or change, do I change the length of a shift? Do I change the way I roster crews on? Do I change the types of job? Do I increase training? What is it that I do? Again, we're back to machine learning and we're back to AI. And that's what you do at this point, is you feed these things into some intelligent systems to go, right, model all of these factors based on these couple of principles that I'm trying to achieve and tell me the optimal outcome. And at that point, we've got the machine doing the thinking for us and telling us, right, here's the thing you need to do that I think will create the best outcome for you. And it's kind of like the smart motorway. And they taught the smart motorway over 6 months what speed to set, and now the smart motorway is setting those signs on the hub road itself, and it will learn over time whether those are the right settings or not. It's the same thing here. That doesn't mean the machine's going to give us the right answer first time. It might give us some things that are wrong, but it will get better over time. We can start to understand that pulling that lever actually didn't create the outcome we expected.
Will the machine ever be able to explain the reason for its decisions?
That's a really
Or will
good
another
question.
machine have to
And that's something
interpret
that's been talked about a lot in the last 6 months.
Yeah.
Is we've created these black boxes of artificial intelligence that aren't able to explain how they got to decision X. And then we've seen things like human bias entering into the decision-making process where humans have created a bias where the machine has become ageist, sexist, racist, whatever it might be, unaware, and we're unaware of that. And we're also putting blind faith in these machines, going, I fed all these factors in, it's giving me the answer, it's intelligent, it might be the right answer. Might just be some coding errors in there and it might be completely wrong. We don't know. So a lot of work's been done in the last 6 months to get AIs to effectively explain graphically how they've reached decisions. It's quite complex, but that's it. It's getting them to expose how it reached decision X. If we change these things, what does that do? So that we don't put our blind faith in machine learning. It can't explain itself. And we don't become beholden to an algorithm that effectively could cease to exist or become proprietary. You know, if you think about that, who owns the algorithms that create these things? And are they transportable? Can I move the algorithm off Azure's AI system over to Google's DeepMind or to AWS or to someone else? How transportable are they, or am I beholden to the cloud provider or AI provider? Act. So we've now got the machine learning, the artificial intelligence, and it's told us what levers to pull and how far to pull them to create the most optimal reduction in worker harm, yet outcomes for this customer's customers. So now we've got to do something about it. But the challenge with this customer is they've got a legacy system. Now, legacy system means it's written in some cruddy old COBOL or Power Builder or something that there is no API. There's no lovely RESTful interface that we can feed things to and get updates. So how do we get the data out of their job dispatch system, which is 50 years old and runs on a green screen, into an AI system which can make some intelligent decisions and back into that system again? Because that's what we want to do now. We want to take data out of one of this customer's inherent systems that runs their workforce, analyse all of this other stuff that we've now got, and feed it back in to go actually put that crew on hold tonight, they need some rest, get this one on. That job's really complex, so can we please bring in these two experts over here who've had lots of sleep, and that job's particularly risky, so we'll bring you guys on because you're fresh. Let's do it like that. And that means interfacing systems that are modern and intelligent with systems that are old and cruddy and can't be interfaced. So we use robotic process automation. Now, robotic process automation, if you've heard of it, is about effectively having a robot. Now I'm talking a software robot here, not a hardware thing. It's so much cooler if it was a hardware one. There's tens of robots in there typing. It's a software robot that effectively takes data out of one system, types it into another system, does some validation. It can do some translation and so forth of that data, and then can type it into another system. So effectively it's doing a really boring, mundane job that humans used to do, but we're using robots to do it, so it's 100% accurate, and we can do some smart stuff with the data along the way. So we do some RPA, robotic process automation, to effectively read off the green screen, validate that data, load it into the cloud to do the machine. Previously you would have had a typing pool, a bunch of people, you know, copying from one system to another. And there's still a bunch of organisations today that have dual screens on their desk because they have two systems and they have to type between the two.
Wow.
So that's where RPA comes in. And RPA lately has also got a bit of a bad rep because it's been highlighted as the thing that's going to take away jobs. You know, all of our jobs are going to be destroyed by robots that are going to do these things for us. But actually this is a really good example of how RPA can actually do something that no human in their right mind wants to do. And would be uneconomical for this customer to employ 50 people to sit in a room and type from one system to another. So RPA actually has some really positive human benefits.
Couldn't they just upgrade the old antique equipment?
You could.
Yeah.
But upgrading that for those old systems,
Yeah.
it can cost $50 to $100 million.
Okay.
It's not an easy thing to do.
No.
Plus, there's business rules and business logic in those things that have
Yeah.
evolved
Yeah.
over 50, well not 50 years,
Yeah,
but
but
30 years,
yeah.
that are undocumented, that live entirely within the code.
In the system, yeah.
And trying to get that out of that system into a modern one
That's
can
great.
be a 5-year-long,
Yeah.
multi-million-dollar project.
Yeah.
Whereas here's a nice, simple, quick
Yeah.
fix. So RPA, to a degree, is, I'd say, it's a 10-year long
Yeah.
quick fix for a problem we're facing. It's not a permanent solution.
Yeah.
And learn, okay? Now we've taken action. Now we can go back to the sensor data, we can go back to the insight, and we can understand what has happened. Are those people safer? Are we seeing a reduction in harm? Are we seeing an increase in output? Are we seeing better uptime with the grid? Are we seeing less faults on the grid? Are our employees happier? Does our engagement survey say yes? We can pull all this data in again, correlate it and go, cool, have we actually achieved what we want? And we start that loop over again. And we go back through the digital process, back through the thinking, machine learning, back into the action, and it's back to the learn loop to understand where we are. And all of that started with IoT. It all started with that, I'd call it a reasonably generic sensor on the wrist, pulling out reasonably generic data that you can get off any particular Fitbit, smartwatch device, nothing fancy about that. But it just shows the power of what you can do with that data when you then combine it with all of the other emerging technologies to create the digital ecosystem.
Ask your questions. I think we had a
Yeah.
fair share of questions. Thank you so much. Thank you, Mike. I think it is such a pleasure to have you here. I think we all enjoy the presentation. I think more importantly, the opportunities that presents. I think what my pickup was, my point was, we're talking about the fatigue, what sort of area you can focus on, a number of industries where this could be applied, for a pilot or a driver or so many areas. It's an exciting starting place. Oh, it's great. Thank you. Thank you for the presentation.